now we're going to put our newfound knowledge about the mean, the median, and how the shapes interact with those two values into practice for a few examples. So we have the mean and median drawn below with vertical lines on the following graphs. We're going to label the shapes of the graphs as skewed left, symmetric, or skewed right, and label the vertical lines as the mean and median. Okay, so if I look at this first graph, this graph is very much skewed right, right? It has a big clump here, and then it has a tail, which is kind of interrupted by this, but it is very much skewed right. And since it's skewed right, we know the mean is pulled towards the tail. So this green line right here is the mean. And this red line resists that tail. It resists the skew. So that's the median. Now, if you're wondering, will the red line be the median on every one of these problems? The answer is yes. But I did make it so that's not the case on the worksheet. So first of all, on the worksheet, it's printed gray. But if you go to the electronic file, it will not be a consistent color. I messed with them on purpose. All right, now what about this? This is symmetric, and you can tell, look at it. I mean, it's kind of even Stevens on both sides, right? That's symmetric. And it's not perfect, of course, because this is real data, but it's close. And yes, these are real data. They did come from somewhere. So both the mean and the median are at the same spot. That's how you can spot a symmetric graph, because the two graphs, or the mean and the median, are very, very similar. Okay, what about this symmetric graph? This one's also symmetric, not quite as symmetric as the one above, but very close. You can see that the two lines are very, very close together. So the median is right here, the mean is right here, but they're basically on top of each other. They're basically equivalent. There's so little gap between the two, so they're essentially equal. Okay, so then what about this one? Well, this is skewed left, as I told you guys before. This is the mean line right here. We've actually seen this graph before. And this is the median. It was one of the graphs I used for skewed left. So this is mean, this is median, this is skewed left. Not a ton skewed left. I mean, they're pretty close together, but it's still a significant gap in there. All right, certainly more significant than these other two. All right, another skewed left one, right? So this is skewed left. This is quite skewed left. This is probably one of the most skewed graphs we have here, because the mean and the median are very far apart. They're the most far apart of any of them, right? So if you want to make a note, this is the most skewed, right? Because there's the biggest gap between mean and median on this one. Okay, so which one's which? Well, the median resists the skew. So the median is right here. The mean is getting pulled towards that left tail that's coming out. So that's the mean. And the last one is very obviously skewed right. That's the mean. That's the median. I should say, I mean, what I'm saying down below about most skewed, that's a bit of a judgment call. There are actual ways to measure skewness that we're not getting into in this course, called kurtosis. So we could find numerical measures of it. But for our purposes right now, that's a useful rule of thumb to kind of gauge skewed left versus skewed right. Oh, and this one's skewed right. I forgot to write that. Okay, so now let's look at another problem with some histograms. So we're going to match the mean and median combinations to the appropriate graphs and explain what's the best measure of center for each. Right, hint, hint, hint. Okay, so 3 of the combos obviously will not work, right? Because there's 6 number combos here. So 3 of them are not going to work. Only 3 of them will, because there's only 3 graphs. Okay, so let's take a moment and look at these two. So if we look at these two, 5.2 and 5.4, those numbers are pretty close together. So my guess is that would be a symmetric graph. 6.5 for the mean, 4.3 for the median. If the mean is bigger than the median, right, then it's skewed right. So this one is a skewed right situation. If the mean is less than the median, that's a skewed left situation. All right. Again, this one's probably skewed left. They're a bit closer, but skewed left. And then this one, they're really close to each other, so that's probably symmetric again. And then 5.1 versus 4.1. If the mean is bigger than the median, it's skewed right. Okay, so that'll help us if we kind of figure that out to begin with, because now we can kind of look at our combinations here. So let's look at this first graph. This is a skewed right graph, very obviously. So it's going to be either B or F. So you have to remember that the mean is the balance point. Recall, the mean is the balance point. So it's where the data set would balance if this was a lever or a teeter-totter. So think about 5.1, right? So here's 3, that's 6, so that's 4.5. So 5.1 is like right there. So think about this little clump right here balancing all of that over there. I don't know if I buy that. And then 6.5 would be right there. That seems like a more fair, even distribution. About that piece over there would balance with that piece over there. So I'm going to guess that this is B, right? Because of the balance point, because it balances right around here. Right? Now, it did ask what would be the better measure of center for each. I will say since it's skewed, the better measure of center, I'm just going to write this over here, better center for this one would be the median, right? Because it's skewed. Or we could put this up here. The better center is the median because this is very much skewed right. Okay, what about this one? Well, this one's skewed left, right? So I have to look at my two skewed left combos. And again, I want to think about the balance point, 4.1 versus 4.8. So I want to put my pen at 4.1. That does not seem to balance the left and the right. 4.8, that seems like it's going to do a better job. It's going to get a good clump on this side and a good clump on this side. So this one, D, is this one. Right? This is skewed left, and again, the median is the better measure of center because it's skewed left. So better measure of center is the median because it's skewed left. Okay, that just leaves us the third one. Okay, so this is symmetric. You can kind of tell it's symmetric. So it's got to be the top one or this one. So we have to think about where the balance point is. 6.4 is over here. There's no way this graph balances on 6.4. That's too much to the left of it. 5.2 is a better measure of the middle, so it's this one. Right? 5.2, let me put it right here. That's the mean. It's 5.2. As opposed to this one where the mean was 6.5, and I should have done that other one, I'm sorry. That one, the mean was 4.8. It was kind of right there. That's the mean. It's 4.8. So that's how you can tell. It's that balance point. All right, now what's the better measure of center for this one? It's the mean. Because the data are symmetric, the mean is the better measure of center. So this one's letter A. The better measure of center is the mean, and because it's symmetric. Whenever our graphs are symmetric, we prefer the mean. And then this is just one other thing to note about the median in particular. So considering the following graph showing the disparity in retirement savings in the US across racial ethnicity groups. So you can just kind of see it's a time series graph, as a matter of fact, if you want to make a note of it, right? Time series graph. Just a little review. Okay, so explain why the graph is discussing the median retirement savings rather than the mean. And that's because if you think about family retirement savings, not from year to year, but think about what it would be for families in the Jackson County area, for example. So family retirement savings, right? How much money people have saved for retirement. What happens is if over here is $0 and over here is millions of dollars, it's like this, right? And very few people are way over here. So it's very much skewed right. And because it's skewed right, they would use the median, right? So this is $0, this is millions. Let me just write millions over here, right? Median is fairer because it resists the skew. It's a fairer representation of the average, right? Because it resists the skew right. Right? As a matter of fact, if you look in economic and financial indicators, it is extremely common for them to use the median, not the mean. The median is used a lot of times in economics and finance. And that's because a lot of things have skewed right distributions, and so we don't really use them, the mean. We use the median instead.